This is just an experiment on the output of the Sunforce 1000 watt pure sine inverter, and as you can see, it's at least the main output is fairly kludgy. The reason it's jumping around a bit is because of the triggering. Trying to get it to be more stable. By the way, the experiment is just running a just using the secondary of the of this one of the 3-volt secondary of this random mains transformer I have laying around. It's I think out of a I think a dead VCR or something of that nature. Don't know exactly what. You see the peak detect is loads and loads and loads of crap in the waveform, although the average kind of shifting around because it's continuous averaging. Looks to be a fairly decent sine wave. It's with proper filtering, which of course the thing does not have because again made in China. And let's see. There's other things about the output waveform of this cursor going to. Okay, how do I? Back in sample mode. Measure. Let's see that frequency is bouncing all over the place because there's loads of crap in the waveform. Come on. Peak to peak. About 3.1, which is about right. Maximum potential, so it's fairly pronounced crap in the waveform. Top. So yeah, there's about a couple volts of crap on this, which means that there's tens of volts on the output. So the overshoot fairly substantial, so again, harmonics are just crap in the waveform are fairly high. Pre-shoot. Average time, full time. Width, duty cycle. So yeah, other things about the waveform. Going into math, FFT, loads of harmonics, at least in logarithmic. Cycles, 5 cycles of division, 10. 25. Getting some things from switching noise from the potential converters in the inverter. And 50 kilocycles. So yeah, 25. Look to be at about. Do cursors work in FFT mode? Off. Okay, frequency. Okay, I'm looking at this, and I just got this oscilloscope today. It's a Owon PDS6062S, so still haven't figured out all the features, but yeah, there looks to be at about 33,000 cycle per second intervals. Or 30,000 cycle per second intervals is random crap. So it's about like 30,000 to 35,000 cycle per second intervals is bursts of crap in the output waveform. See what the level of them is relative to this is 0 dB level. Yeah, they're about 32 dB down from 0 level. So yeah, still a fairly substantial amount of crap on the output. FFT off. This is one other thing about the waveform. So if you zoom way in on it, jitteriness, by the way, is just caused by, again, crap in the waveform causing triggering issues with the oscilloscope, but that's not the fault of the oscilloscope, that's the waveform. There are about these pulses at about roughly 150,000 cycles per second or thereabouts. So I got a one of that. So there's fairly regularly spaced. Those are about 71,000 cycles per second, 14 microsecond spacing. This bigger pulse is again, 35,700 cycles per second. They're about 28 microseconds. So yeah, that's all going to be switching noise. And then these slightly closer spaced pulses in each set. Those are 156,000 cycles per second. But yeah, and also if you zoom in a lot farther, you can see fairly substantial ringing at about yeah, 4.3 megacycles. So yeah, there's that's probably where a lot of the QRM is coming from. It's just all of the harmonics from all this crap in the waveform. But I imagine that this will be fairly effective at causing all kinds of nastiness in the shortwave reception. And let's see if I can get an amplitude potential. Accuracy, I want to get that about okay, well, 1.76 volts, so yeah, there's probably a good probably 30-40 volts a ripple of just crap on the output of the actual inverter. And of course that's also not taking into account the attenuation effects of this transformer, because this is designed for low losses at 60 cycles per second, not orders of magnitude greater than that. So all in all, pretty nasty waveform, and that's generally why I use a mains filter when running anything through this. And for comparison, this is normal mains electricity, which is a fairly clean sine wave aside from these bits of clipping at the peaks, which is again just due to the billions of switching power supplies and compact fluorescent lamps and other associated things on the grid that have high current draw at the peak of the supply waveform. I can see if I do peak detect on that, much less crap. So yeah. The average, which is again sine wave, as is to be expected.